A non-tropical low formed about 700 kilometers (435 miles) north-northwest of Wake Island at around 0000 Coordinated Universal Time on July 18, 2017, which transitioned into a tropical depression about 1 day later. In the afternoon of July 19, the Japan Meteorological Agency (JMA) began issuing tropical cyclone warnings on the system, expecting a tropical storm within 24 hours. Although outflow was weak for the partially organized system at that time, low vertical wind shear and sea surface temperature (SST) at 29°C were conducive to development. Originally retaining some subtropical characteristics, it began transitioning into a fully tropical and warm core system. Therefore, the Joint Typhoon Warning Center (JTWC) issued a tropical cyclone formation alert to the system early on July 20, when fragmented deep convective bands had wrapped around its broad low-level circulation center (LLCC). A point source positioned over the center also improved outflow aloft. At 12 o'clock Coordinated Universal Time, the system intensified into the 5th Northwest Pacific Tropical Storm of 2017, which was assigned the international name Noru half a day later by the JMA operationally. Besides, the JTWC upgraded the system to a tropical depression at 2100 Coordinated Universal Time. 12 hours later, the JTWC upgraded Noru to a tropical storm, despite its partially exposed LLCC. At the same time, it started tracking westward along the southwest periphery of the subtropical ridge, STR, positioned to the northeast. Noru struggled to intensify significantly for 2 days owing to relatively low ocean heat content values and its asymmetric structure, until it developed into a severe tropical storm at around 1800 Coordinated Universal Time on July 22. Subsequently, Noru slowed down and remained stationary, due to a complex steering environment consisting of ridging on 3 sides. The steering flow also transitioned from a subtropical ridging to the west to a near-equatorial ridge to the south of the system. Noru rapidly intensified into the first typhoon of 2017 around 12 o'clock Coordinated Universal Time on July 23, marking the latest occurrence of the first typhoon since 1998. It featured a 20 km (12 miles) diameter pinhole eye that embedded in an extremely compact core located about 900 km (560 miles) east of the Bonin Islands, thanks to moderate eastward outflow, anomalously warm SSTs and low vertical wind shear. After that, the eye repeatedly reappeared and filled due to increasing vertical wind shear offset by improving poleward outflow into the upper low associated with Tropical Storm Kulap. Noru also started to track east-southeastward under the steering influence of a near-equatorial ridge to the south. On July 24, a Fujiwara interaction between Noru and Kulap started. As a result, Kulap became directly located to the north of Noru early on July 25, and this situation allowed cold dry air to intrude along the western and southern periphery of the typhoon, making Noru weaken slightly with the significantly shallower convective core. The primary steering influence for Noru was still a near-equatorial ridge to the south, but another ridge was also building in to the east, turning Noru northeastward and then northward. Although vertical wind shear relaxed somewhat with the robust eastward outflow channel on July 26, the reduction of mid-level relative humidity and slightly depressed SSTs at 26°C to 27°C tempered intensification and even eroded the convective structure. Having finished a cyclonic loop and tracking west-northwestward along the southern periphery of a deep layered ridge to the northeast, Noru showed some signs of transitioning to a hybrid system, with an upper-level low nearby and a thermal structure more indicative of a subtropical storm. However, Noru reformed a 35 km (20 miles) diameter eye late on the same day, and while dry air was still entrenched across the southern portion of the typhoon, the extent of the dry air had shrunk and the moisture envelope was expanding, forming a hospitable cocoon for the system to reside in. On July 27, Noru began to track westward along the southern periphery of a deep layered ridge to the northeast. The upper-level environment was extremely complex, with a tropical upper tropospheric trough cell having developed just to the southwest, another upper-level low to the southeast and an induced anticyclone just to the south and extending over Noru. The aforementioned Tut cell to the southwest was also providing a weak source of outflow. Moreover, the combination of the complex upper-level outflow and low vertical wind shear was helping Noru to maintain intensity. At around 0000 Coordinated Universal Time on July 28, Noru slightly weakened into a severe tropical storm when approaching the Bonin Islands. Dry air completely surrounded the system with weak convection wrapping around a ragged eye. Moreover, vertical wind shear was high, but the shear vector was in general alignment with the storm motion, with resultant relative shear values in the low to moderate range. At the same time, the steering flow transitioned to the subtropical ridge centered over the East China Sea, causing Noru to track southwestward along the eastern boundary of this STR. Despite warmer SSTs at 28 degrees Celsius to 29 degrees Celsius which supported intensification for Noru in the area, the complex upper-level environment with a tut cell to the southeast and a ridge far to the north combining limit outflow, while dry air continued enveloping the typhoon and isolating it from any significant moisture. Noru reformed an eye at around 9 o'clock JST 0000 Coordinated Universal Time, on July 29 while situated 70 km 45 miles to the east of Chichijima, the largest Ogasawara island. Based on the observations from Iwota, the JTWC downgraded Noru to a tropical storm at around 1800 Coordinated Universal Time, at which time the system was tracking directly southward along the eastern periphery of an extension of the STR position to the west. Early on July 30, Noru began to improve its convective structure, making both of the JMA and the JTWC upgrade Noru to a typhoon again. Over the following 24 hours, Noru rapidly intensified, and the JTWC reported that it had become a Category 4 super typhoon about 225 km 140 miles south of Iwo to at around 1800 Coordinated Universal Time, with 1-minute sustained winds at 250 km per hour 155 miles per hour, though operationally it was put at Category 5 strength with winds at 260 km per hour 160 miles per hour. The typhoon took on annular characteristics, with a symmetric ring of deep convection surrounding a 30 km 15 miles well-defined eye and fairly uniform cloud top temperatures. Environmental conditions were favorable with radial outflow, enhanced by a poleward outflow channel into the Tut and a subtropical jet to the east-northeast. Noru's previous southward motion also led itself to the warmer area with SSTs at 29 degrees Celsius to 30 degrees Celsius, favoring intensification. At this time, Noru began to drift westward within a competing steering environment. On July 31, Noru reached its peak intensity at around 0000 Coordinated Universal Time with 10-minute sustained winds at 175 km per hour, 110 miles per hour, and the central pressure at 935 hectopascals, 27.61 in Hg. It remained an impressively annular system with a clear eye but lacking banding features, yet the JTWC downgraded it to a typhoon in the afternoon because of recently warming cloud tops. Traveling northwestward over an area of low ocean heat content and isolated from well-defined outflow, Noru's gradual weakening trend became more evident early on the next day, which is also indicated by the JMA. A microwave imagery depicted a weakened eye wall, while the eye was temporarily not as clear as before. Since late August 1, Noru presented a 95 km 60 miles diameter large but ragged eye. Yet the convective ring surrounding the eye gradually elongated, especially on the northwestern quadrant. Meanwhile, microwave imageries even depicted a break from the northwestern portion of the eye wall. Noru was establishing a poleward outflow channel that tapped into a passing mid-latitude trough located to the north on August 2, and a strong near-equatorial ridge was steering the typhoon towards a weak area in the subtropical ridge to the northwest, being the result of that passing mid-latitude trough. The ragged eye of Noru became enormous on August 3, with the diameter about 110 km 70 miles. Despite maintaining a good poleward outflow channel into an upper-level low to the northeast, the mid-latitude trough just to the northwest caused subsidence along the northwest quadrant and offset the favorable conditions including low vertical wind shear and warm SSTs, making deep convective bands shallower more and more. Having tracked westward relatively faster for one day, Noru slowed down again and turned northwestward on August 4, along the southern periphery of a deep layered subtropical ridge over the Korean peninsula and western Japan. Deep convection in the northern portion was very shallow early on the same day that prompted the JTWC reporting a partially exposed system. In the afternoon, convective bands re-intensified and surrounded a 70 km (45 miles) eye, yet the JMA radar depicted a much larger eye, with the diameter about 95 km (60 miles) to 110 km (70 miles). On August 5, deep convective banding presented predominantly in the southern semicircle of Typhoon Noru, owing to strong equatorward outflow and the terrain of Kyushu as well as the Osumi Islands. In spite of moderate vertical wind shear, the very warm SSTs at 31 degrees Celsius of the Kuroshio still help sustain the strength of Noru. However, the system weakened into a severe tropical storm again about noon when the eye had completely deteriorated, as an extension of the subtropical ridge was suffocating the typhoon on the northern periphery, resulting in the deteriorating poleward outflow channel. Noru remained almost stationary and looping around Yakushima until it accelerated northeastward off the southeastern coast of Kyushu on August 6, along the western boundary of a deep layered ridge extension located to the southeast. While the eye was struggling to reform, a strong convective structure started to wrap around a growing ragged eye feature later, over the SSTs at 29 degrees Celsius. On August 7, Noru passed near Moroto, Kochi at 10 o'clock JST 1 o'clock Coordinated Universal Time, on August 7 and made landfall over the northern part of Wakayama Prefecture at 15:30 JST 6:30 Coordinated Universal Time. Both of the JMA and the JTWC downgraded Noru to a tropical storm at around 2400 JST, 1500 Coordinated Universal Time, for the weakening system tracked over the Japanese Alps. Noru emerged over the Sea of Japan from Toyama Prefecture at around 5 o'clock JST on August 8, 2000 Coordinated Universal Time on August 7, and then continued weakening, as deep convection had gradually deteriorated because of the mountainous terrain. Thus, the JTWC downgraded Noru to a tropical depression about 5 hours later and issued their final warning owing to the poorly defined and disorganized LLCC in the afternoon. Noru subsequently became an extratropical cyclone at around 2100 JST, 12 o'clock Coordinated Universal Time, before the system was declared dissipated by the JMA on August 9. In Japan, hundreds of flights were cancelled ahead of the storm, and thousands of people were moved to evacuation zones. As of August 7, 2 people had been killed by the passage of Typhoon Noru, both in Kagoshima Prefecture. 1 man died due to Noru's high winds. The other Noru victim was a fisherman. Total economic losses in Japan were counted to be $100 million.